Because last time I didn't do this, and then Richard was like, "Where's the link?" Richard was not with us. Yep. Oh, that's so cute. So cute. Oh, no, no, no. You're not allowed to see what's on this one. No. No. You already slandered my name with this. All right. Okay. So, Alberto. Yeah. So last class. Okay. So let's try to remember what happened. Okay. With the example from the pirate. So can I be seen there? Yeah. Look at that. Pretty nice, eh? So we have an island, right? I have good old pirates. Alfonso's on chat. Oh, thank you, Alfonso. Nice to see you as always. Now I can check the chat after, but yeah, if you could just put his number in the book, thank you. All right. So we have our pirate with little cannons, make it a little bit cuter. So I've done this example a couple times, but it's always good to reiterate. Make sure you keep it on your mind, okay? Because we're gonna be touching in this stuff again, okay? The mountain with the skull in the middle, the shack where the crazy guy lives. Yeah. So now you have your pirate here, right? And he just raided a Spanish vessel, and now he has a lot of booty. And he wants to store his treasure somewhere, right? So, but now he needs to record his path. Alberto, how would he record his path? Right. What is the trail made up of? Lines? Well, no lines. What makes lines? What is the component of a line? Oh, 2 points, right? Right? So 2 points, right? So to get started, right, we need the first point or a start point. So usually the start point 0, comma 0, right? 0, comma 0, x, y. Yeah? Now, so let's say I move a bit to the right. What happens? X-axis increase. Right. There you go. So the pirate decides to move a little bit to the right. So now the x-axis is 1, comma 0, right? And he records it. So he starts writing these guys down. What does he write them down on? What do you mean? Like, where does he needs to start putting these ones down? Where does he put them down on? What thing have we been using? Like bit. Right, right. But what's the data structure? What is the thing that he? Yeah. An array, of course, right? The array. So the array, right? So in the array, he goes 0, comma 0 here, comma 1, comma 0, and so on, right? Yeah. And then he just keeps going, right? He keeps storing like output, like as he keeps as this thing keeps growing, right? He is adding more and more stuff to this, and then he does his little trail until he reaches the X, right? And we also saw that we were using another algorithm to start deleting the ones from the back, right? So we make one, and then all of the stuff stays on the array, right? Because it would be very expensive to delete the array, right? But we basically only read the last five of all this to make the snake trail, right? Right? So that's for the beginning part, right? Now, so Yeah, this horror was like using this marker, like was going rough on him. Whoever was using that marker was being pretty rough. Okay? Yeah. So that's how we make the snake trail happen, right? Now, so now let's put this into what or what we're trying to accomplish next. Okay? Is that we have two bodies, right? Two bodies, one here, one here. They're both circles. Remember, oh, do you remember what for collisions? What was the three things that we need to take into account? Yeah. Uh, Distance, position. So position is distance and position, same thing. Well, so position is the first one. What does this thing have? Like, what is a property of the circle? Oh yeah, radius. Radius. So radius could be how big the circle is, right? So the size of this thing, right? The size. And also, what's another thing that this is a circle and not a square? This is a circle and not a square. So what? The shape. Yes, shape. Okay. So this is the three things that we need to do to have our collision algorithm. Okay. Take all of those into account. Other stuff in more advanced algorithms, but for now, we all for like the basic one, we only need this. Okay. So what does the collision algorithm mean, or what does it do for us? Okay. Make what it's doing, it's that it's calculating if we are touching something. Okay. We're calculating if we're touching, right? But since the bodies move according to the frame rate, we have to calculate every frame. Okay. Every time that the bodies move, there's a possibility that something could happen and they could touch. That, for example, out of nowhere, they get like a super velocity and like they're like they could be like 1,000 miles away, but they get a velocity of 1,000 miles per nanosecond, and basically they just basically teletransported right next to it. So basically, we need to keep that into account. In like more sophisticated algorithms, you would uh you would also kind of take like how that distance like into account. So like for example, you want like if realistically nothing can move at like 10,000 miles per nanosecond, right? Uh, then you realistically don't need to render, for example, the things that's what the render distance means, right? Is that you're not taking into account things that are too far away. Okay? Yeah, yeah, Minecraft. Exactly. This looks like something else. It's okay. So, hey, it's not purple at all. Wait, actually, can you? Hey, this is not. Oh, there you go. Oh, that was not seen. Like, there. Okay, cool. So now, so we need to basically make a formula that tells us if they are touching. Okay. So as I said the other time, the one for circles is pretty easy because we can use the radius, right? The shape, it's very simple, right? The shape is a circle, right? And we have uh, three things to take into account: the distance and the radius of each. Okay. So we can put this basically as if uh the hypotenuse of like this distance, right? Right? If the h of this of the if the h is smaller than radius 1 plus radius 2, they're touching. Okay? So let's write that. Okay? Let's write that and make something happen. So for example, we can say that. So let's just make it log it on the screen first, and then we can make something happen after that. Okay? So let me switch into my other screen. There you go. Perfect. All right. So important, right, is to write and also I will start with only two things at the beginning. So I'm gonna get rid of bolt 3. Okay. So I only have to worry about two things. Yellow. I only have to worry about two things here. Now, so, and also get rid of the update here. Let me just check that this is going to work. Bolt 3, bolt 2. Let me see, where is that? Also, let me get so we can actually see what we're doing. Let's get rid of this index because I was printing all this stuff before. Make sure you get rid of all this so stuff works out. Now it should just work out better. Uh, there, and just bolt 3 change position. Yeah, that's what. Just let me change that out. Just comment this guy out. Work. Yep. So now we have this. So now basically what I want to do is check if this ball 1 is colliding with this ball 2. Okay? So we take those three things into account. We have all those three things, right? So let's take a look at these things. So in here we have the the size. Actually, no, we have in entity. I believe an entity. Yeah, an entity. We have the size. So for our case, the sizes are the same, although this could be different, but we'll take that into account. We might have to do some modifications here in order to make the size the inside of the screen. Actually, let's do that real quick. Yeah. So go to entity and go to draw, and oh yeah, so this is what we're gonna do. So let me put this on the screen so we know why I'm doing this. This is important, otherwise it won't work. So remember that things get drawn the same way that things get drawn on a screen, right? They get drawn by their top left, the corner, right? So what's that? That's it. You're watching the screen, right? Yes. Yeah. 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 So when I call the method lit, right, to draw something, right? That basically, and I also tell it a spot to draw it on, right? That picks this spot here, and then it draws the picture like so, right? It ranges from here and from here and draws the square, right? So the position of the figure is this spot right here, right? So now for our model to work, right? Because we're working with circles, right? We need to get the center in order so we can get the radius. So then we can check if oh, you weren't here a second ago, but basically the way that we're gonna check if these two things are touching is we're gonna get the delta of the distance between these two, right? So the difference in x and the difference in y between these two, right? Then we're gonna get the hypotenuse, right? We get the hypotenuse, and if the hypotenuse is smaller than radius 1 plus radius 2, then they're touching, right? Makes sense, right? But before we do that, the position, the center of our circles right now is here. So we need to shift it to be here. So how do we do that? We basically make it so that their position is basically this minus half of the width. So this would be the width divided by 2, the height divided by 2, right? And then basically we get x minus w divided by 2, right? That gives us this point in the middle. and then y minus h divided by 2, that gives you that point. Makes sense, right? So we're gonna make it so our game draws or things like that first, okay? So let's do that first real quick. So I'm gonna do that right now. What? I'll show you. Yeah, I'm gonna make that right now in the program. The more important thing too is to make it on the loop. So that calculation needs to happen, and we'll get into how the arrays play into this later too. But how they we need to have that needs to happen for every body. Okay. So what right now we're gonna only make it happen with two bodies, but we'll make it happen with everybody. Okay. So cool. So okay, first, it's simple. We'll just change how the draw function works. So the draw function will be self.position, and instead of drawing it exactly in that position, we'll draw it on the position. Then we will have to divide it. No, it'll be for the x, it will be plus uh, this dot. Did I have the? Oh, you do have to get the size because the size is not being put into a thing, into a attribute here. So I'm gonna add another attribute for the size. So self dot size equal to size. If you don't do this, this will not work. I remember I'm getting the size from here. I'm storing it inside of part of the entity. Is something incorrect here? Oh, it's probably this part here. Oh yeah, and in here, basically, I'll do that little formula that I put up there. So the x value would be self dot size. I get the first element, which is the x, self dot size divided by 2. And there's also a more efficient way to do this, but for now, I'm just going to do it this way so you can see the direct way. Because right now, I'm basically dividing every time. And since the y is inverted, I have to do a plus on the y. Okay, so this thing right here, I'm gonna run it right now to make sure. So self.size. So this will be the size on x, which is the width, and self.size one would be the size of on y, which is the height, right? And then I divide them by 2, right? That gives me the half, and that's that. So you got this, Alberto? Yeah, I will see. Oh, sorry. Let me make this bigger for you. Sorry. Let me know. Let me know. You need to slow down? I'll slow down. There you go. So remember, we're modifying the draw function, okay? So it centers the ball. You got it? Go ahead. No. Yeah. Take your time, take it. While you do that, you want to do it. You can get from the local route. Yeah, from yeah. Okay, sure. 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 What are you doing? Unity, physics engine, right? It's not Unity. This is Pygame right now. But physics engine or? Physics engine, yeah. That's cute. Not for the picture at least. Sure. I mean, it doesn't show in the picture right now, but oh, sure. Oh, you're gonna take a picture of that? Sure. Natural. Sure. If you want to check out the code on my GitHub. Now, while he is doing that, so this part interesting a little bit, but the thing is that, for example, that it is simple because you didn't work here when I was talking about this, but in order to for collisions to like or collisions engine to work, we gotta take those three factors into account: position, size, and shape. Okay, why? So position is where are they, right? One's here, one's there, right? So because the where it's being brought is based on x and y, right?
Square, right?
Okay.
Because the square, I remember like from FIFA.js, the square has a certain, well, FIFA.js was already built, like, but the
This
square
was
has
like
points.
this is basically the same.
Okay, the square has points, right? So each point has a different axis, right? So then what does it mean when you choose this specific point to make it here? Wouldn't it change the shape?
Your, for example, when you use the
Would you have a new variable called point? No, but then how would the shape know that it's connected to a point?
so you
Well, that's
use
actually pretty cool because that's great.
but what this is, okay? This is like a function that draws a picture, right? You have a picture that is just a square, right? And you draw the square, okay? With a specific amount of pixels, right? In P5, it works like this too. When you draw something, you choose a point and then it draws it like this, always, okay? Even for rectangles. Rectangles, you choose the top left point and it draws it from there. So then you choose the XY is this point, and then is the width and the height.
Okay, I see.
Yeah. So the width is this and the height is this, and this just connects that.
Okay.
Make sense?
Okay, okay.
Yeah. So that's how you know that. Now, why I'm doing this part is to center the point.
Wouldn't it have the point and then wouldn't it be this would be XY and then length width though?
Yeah.
Or height width?
Yeah.
So then XY would be your starting point and then length width would just be this and they connect because it's a square.
Yeah. So but there you're hitting into basically shape, but I'll get into that in a second. So now, so yeah, you have the position, right? The position is this, but with what I'm doing with Alberto right now is I have just transposed the position into being here or translated. I think that's translation. I have. Are we showing this? We should probably showing this while I explain this to you.
Pretty much it is a translation too.
I think so. Yeah, I think this is a translation. Better said. Oh no, we were showing that. Okay, cool, cool. So the translation, right? The translation shows we go here, right? The translation moves it from here to here, right?
Yeah, yeah. So to the half.
Right.
Okay.
So that's for the position, and the position is in the middle. Now, the size, right? The size of a circle is based on what? Radius, but yeah, diameter, radius. Okay.
Yeah.
Yeah. So that creates the circle. We're doing a circle right now. Okay. And the circle is the easiest one. Because the circle, you're able to do this with circle. Okay. Because think about this. So the circle, with other circles, you just do this method, which is the easiest. But now think of a square, okay? Think of a square. Now, squares are different because for a circle, right? If we were circles here, right? Actually, if we were circles here, look, at this point, they're not touching, right? Using the same logic, if they're squares, they're not touching at this point, even though they are touching, right? Because you see the circles don't touch.
Oh, but you would make a circle inside the square?
No, no, no. I'm just telling you that, okay, better said. Okay. These squares are touching, right?
Yes.
Okay, but the logic is made for a circle, right?
Okay, yes.
So the circle will only detect if a circle and another circle are touching. So are the circles touching?
No.
So the logic doesn't work.
So what would you do for a square?
Now that is when it gets harder, but I'll get into that in the next class. But well, actually, we'll see. Maybe we can get to that in this class. But it's basically another method.
Can you first part one, part two, just so I can see it?
What do you mean?
Like, so if the radius is three, right? It would be 6. And if height was less than 6,
Three, three, and let's say that it's separate. So if the separation is 3, 3, okay, r equals 3, and let's say that the separation between them is For if they're not touching, it's probably gonna be something like
20, right?
yeah, it will be like 8
Okay,
and
so
10. This is likely not touching. So then you get the hypotenuse of this, and if the hypotenuse of these things is lesser than 6, then they're touching. It's probably not. Make sense? Yeah. Okay. No.
I have a question though.
What?
Because how would you? Okay, let's. Okay,
You want to see it? It's gonna. I'm gonna make it happen right now.
because it wouldn't surpass, right? It wouldn't overlap.
So that depends on what we make happen. Okay, you're gonna see that. Okay. So now the thing is, that's the cool thing about it, because then when they touch, then we can do something. Okay. So first we need to register that they have touched. Okay.
Right now they overlap. If we just put
Yes, they will overlap at this point. Yes. So cool. So we have this. You have this, Alberto? Center? Okay, dope. So now they should be drawing on the middle. Let me just check that. Make sure that, okay. Yeah, they're a little bit, yeah, you see, look at that. You see how now they fall to the bottom? Because we made the floor, so now like basically they're going over the floor, which is fine. It's fine. This means that that everything is working, okay? So there's a thing that makes it, that's like an invisible barrier for the ground, but don't worry. That means that it's working. Okay, so now let's make that thing happen there on the top. Okay, so to do that, remember, we need to check this every tick. Okay, so I'm going to write a little function here. We'll call it collision. Okay, I'm going to call it def up here. We're going to call it def collision. Okay, in the main.py. Okay, def collision. Okay, there you go. So every time that I call def collision, I want to check all of the bodies that I have on my stuff. But since I only have 2 bodies, I only need to do 2. So I'm just gonna do if uh what are the names? So it's a snake and it's ball. So snake. Uh so let's get the radius first. I'll make this as simple as so we can actually let's get the hypotenuse first. Okay. So to get the hypotenuse, we'll do so delta x is equal, and this is not the best way to do it, but I'm just making it very visual, so you know, delta x is equal to is going to be snake dot is called position, yeah, snake dot position 0, 0 is for x minus is ball 1 minus ball 2 dot position 0 delta y is equal. You know what delta is, Alberto?
Delta. Difference.
Yeah.
Difference.
Yeah, no, yeah, that's perfect. Yeah, difference. So the basically what I'm saying, delta x and delta y, I'm saying the difference on x and the difference on y, right? So I'm getting that little triangle up there. Okay. Position 1 minus ball position 1. Okay, so difference in y, difference in x. Okay, so now I get the hypotenuse. So I'm just going to call this h is equal to, I think it's just math. How do I do that? I have to import math, I think. So I need to get the square root. Import math. Yep. And then in here, I do math dot square root of delta, oh, delta x math dot uh square, no, what do you call it when you, what is the name of the thing when you like do like times 2? No, you know what, I'm just gonna do this. Yeah,
Power.
power, yeah,
X.
yeah, squared, but no, okay, so then it would be square root of that plus that. So it would be so delta x times delta x plus delta y times delta y. That gives me the h. So let's just to check out real quick, we'll log it. So so now remember, so this is just a function, right, Alberto? So this function is not doing anything until we call it, and we're gonna call it every tick. So I'm gonna call collision here, collision, like that, call it collision every time, and I'm just gonna log the h just to see what I get, and see if what I get makes sense. So print h. So this should be basically the distance between the two balls. So let's run it real quick. Oh, yep, looks like it's correct. Look at that. You see how it gets bigger the more I get far away, and the more it gets smaller, the closer I get, right? Perfect. So the H is correct. Now let's run the formula. Okay? So what I'm gonna do here is, and this, we can probably structure this. I would actually like you to structure this by yourself in a better way, but I'm gonna just do it kind of in a crude way, but whatever. So I know that all the radiuses are basically the same because that's how we did it, but the radius here, for example, let's so I know that this is the size, right? This is the size, so I'm gonna just name it as, I'm gonna make a variable and name it rad. So radius is gonna be equal to 50, okay? And I'm gonna replace that in all these places, radius, comma, radius, and then here, radius, comma, radius. Make sense? Yeah?
Radius.
So basically, I just made a variable radius, right? And then I put the variable as the size of the entities that we're creating, right? Just so I can use that for the equation purpose. Okay?
Yeah.
So actually, no, this would be radius, this would be diameter. Oh, let me change that. F2 to change diameter. Diameter. That's diameter. And now rad is equal to diameter divided by 2. So there you go. We have the radius. So since they both have the same radius, I can just use that. So then I'm gonna basically do my if statement here. So if h is smaller than radius times 2 because they both have the same radius, then print they are touching. Is this correct? Yeah, it looks like it's correct. So let's give it a go. This thing. All right. So nothing yet. And as soon as I touch the ball, it should do that. And look at that. You see that? It says they're touching. So now let's do something. So print they're touching. So if they're touching, then I'm gonna do snake dot velocity y plus, it's gonna be equal to minus 50. That's too much. Minus 10. So basically, when they touch, the snake will jump. Okay? So take a look. I don't need to fix the trail, but look at that. And I didn't touch it. You see that? So you, for example, you can make it happen. So 10, let me switch it to 5 because that's still a lot. So there you go. So 5. So we did so this is a pretty simple one, right? So you see, I touch it and that happens. And I'm not pressing the jump button or nothing. Okay. For example, yeah, to make it more showable, we could make them both because there's no keybinds for the other ball, right? So I'm gonna make ball two jump two dot velocity comma 1 is equal to -5. This is gonna be interesting. Bang. You see? And this is the first time that the other ball has moved. Let me disable the trail because that's like getting distracting. That is snake, enable trail. There you go. Much better. Look at that. You see, they're jumping exactly. Yeah. Look at that. So that's the first step of collision, right? Pretty simple, right? Is the most simplest of the simple things. Now, in order to make all of this work better, we actually need to start doing some changes to the structure. So, for example, actually, I would like to because you saw that I did a couple of wacky things, right? So, for example, I made it so the radius is done in a wrong way, but I just did it that way for demonstration purposes. What do you think would be the right thing to do now?
Like, how do like the way you did it? Like, how do you make it better?
Yeah, there's a thing that we need to change. There's a couple of things that I would change now.
Um, honestly, I wouldn't know because like, I understand the logic, but like remember what I told you last time? Like I understand your logic. I don't. I wouldn't know how to like approach it
No
like
worries.
by myself.
No worries. Don't worry about it. So
Like
mm,
like
just take a guess. So whatever you consider.
yes, maybe you make like a
The shaft.
like
The shaft.
self.
Sorry, what?
The shaft. Someone asked you to do the shaft in the room.
Oh yes. Oh, wait, what? Is this a class room? Yes, I we are in room 2207. Yeah.
Yeah.
Uh, I'll answer in chat. Yes, room 2207. I think this person's watching on Twitch. Interesting. Okay, cool. There you go.
Um, so I was gonna say maybe you can use self like I don't know self delta x. So like have I don't know multiple collisions.
Interesting thought. Interesting thought. So self. So for example, there is a couple of things that we will have to do for that. Yes, you're correct in that. The thing is that, and you're in a right trail. The thing is that one thing that you got to think about is that delta, right? Delta is relative, right? So you have to be thinking about like the delta is always calculated every time that you are getting a new point of reference, right? Because the delta, like for example, my delta to you is my distance to you, right? But my delta to Stephanie is a different delta, right? My delta to a guy in China is a different delta, right? So it all depends, like on a point of reference. So you cannot really store it inside of a inside of a inside of an object. You can only like calculate it once you need it, right? So, for example, the delta that shows up there, right? The delta that shows up there as like the distance between the two objects,
Yeah.
that's why I have to calculate it. That's why I have to get the hypotenuse. That tells me the distance that, and keep in mind, that doesn't tell me the distance from each other. That tells me the distance from the center of each other, right? From the center middle point mm, that is based on the shape. Now, think about this. Our entity or entity class, right, is taking a couple of things for granted. Okay. For example, one thing is that our entity will be a will be a rectangle. Okay. It takes that by default. Why? Because that's how it draws it, right? Or ball here, or ball here might look like or ball might look like a circle, but you know that that PNG is a rectangle, right? It's a rectangle that has invisible corners, right? So me doing that like radius thing was a kind of like a patchwork for this thing just to work, whatever. But now, if we really wanted to do this the right way, for example, what I've seen, like there's different approaches to this, but for example, we could create another class, okay? So now the entity is supposed to just represent like a body that exists, right? You do not know what? The shape of the body. So then you could define the shape with a class. So for example, then a subclass of the entity is a circle. And another subclass is a square. And another subclass is a poly, what is it? Poly, many sides? What is that called? Um, Polygon. Polygon. Yeah. The many sides is a polygon. So what we need to do now, uh, I'll talk about real quick how this works for a square. But okay, and I do want you to do this homework. Okay, I want you to try to do this. Okay, is to turn this entity class. Okay, and instead of like making the snake sock, because we already did this, right? We imported entity to the snake, right? And the snake is just like entity with a couple of extra things, right? No, I mean the snake is entity with a couple of extra things, right? Now, what I would want you to do is to make a new class that is circle and another class that is a square, okay? And that does, like the circle will, instead of having the sides, will have just a radius. And the square will have the size of like set of shape, right? Like it will have width and height, but the circle will only have radius. Make sense? So that's the difference. So now, let me talk real quick about how where we're actually from. Uh, is that to me? Uh,
Just
oh, are you just like checking it out? Oh, it's Miami-Dade College, Miami-Dade College North Campus. North Campus, I guess, yeah. USA, Florida. Yeah. Uh, yeah. That's the campus. Netaji? Netaji? I hope you say your name wrong. Your name right, not wrong, right? Okay. Nice to see you here. I hope you're enjoying the class. Okay, so that's the stuff for the circles now. So now what are we gonna do for the squares? So the squares is when it starts to return a little bit more complicated, and you can start to appreciate how this type of algorithm is like in the top level is crazy complex. Okay, so I'm recording myself, right? Okay, cool. So we use describe how to get the thing with circles, right? How to get the thing because we knew their positions, we knew their size, and we knew their shape, right? Now the shape of a square gives us a couple of other challenges, as I just described before, right? That for a circle, we cannot use the radius because the radius is not the same for a square, right? The square has a different radius here than it has from here, correct? Okay, so what can we do? So with squares, the first thing that we want to do is basically we use boundaries, okay? So you do this in when you do what is this called? In in uh I think just in algebra, you use and you start drawing graphs, right? The what is the graph of x is greater than 5, what does that graph look like in a Cartesian plane?
Looks like x greater than 5. It's a line going to the right.
Yes. Well, okay. Let's say that is a 3D graph. No, not three. A 2D graph. My bad. It's a 2D graph. So we draw the line on 5. So x5 here, right? And we say that our answer is everything greater than 5, right? So this is our answer. Okay. So when we're talking about the body of a square, right? We can define it in a similar way. Okay. How? So let's think about it in that same way. I'm gonna draw it here in the middle. So I'm gonna draw it here. I'm gonna put it like that in the middle. Okay? And we have a square here. Okay? As of before, we know the top left corner, right? We know the width and we know the height, right? I'll do.
Yeah, that was
Yeah.
like the middle point on the side of the square.
Mm-hmm.
That's what I was doing.
On
Like,
like here, a function for the
yeah, yeah, right. No,
um maybe I will have to. I'll just tell you the generic way, but if there might be a specific way for Python, I'll get into that one. But it probably kind of differs to this way. Okay. So now, so we have this, right? We know also the x and y values, right? We know the x and y values. We also can know all these other values based on these four values here allows us to know all these other values, right? Because what is this? This is x plus w. What is this? This is y plus h, and this is x plus w, y plus h, right? So we know all these other points too, right? So if we define them as inequalities, we can use that to create a mathematical square. So basically, the way we do this is we say that we make basically four conditions, okay? And we say anything that is above these 2 points, above this line, so anything above this line, so anything from here to there, right? We make that's our first inequality, okay? Then we make another one here, and we say from everything from here to here, okay? Then we make another one, everything from here down, and another one from here to the left, okay? So when I take all this out, right? And this looks basically like, and I read all these things with all this other stuff, it's gonna look kind of like this, right? And I say basically just the things in here, okay? And if all of those conditions are true, if all of these conditions are true, then you are colliding with the square. Okay? So I don't have time to do this one right now. We'll do it next time. We'll do it next time. So yeah, so, but you can think about it in this way, okay? We're gonna use four inequalities, not five, four inequalities. Uh, we just did one. Greater, yeah, greater than,
oh yeah, greater than or equal to greater.
yeah, greater than, yeah, and that's it. So you make that, and let's say the first one would be x, the just the x, and we're talking about x1 is smaller than x2, x2 minus w2. So that's the width 2. So basically that you are infringing in the space of x1 with the value of x2. Well, actually, it would be the other way around. My bad. But so it would be x1 plus w1 is smaller than x2. Yeah. So that is the most left side corner of the second square is smaller than x1 plus w1. So the first square plus its width. So basically, you're talking about this side over here. So x plus w, right? So if the second square is basically here, or like, better say, if the square is here, so basically the x position, right, is lesser than this x position plus the w you're touching. Make sense?
Yeah.
So now you need to do that for all the sides of the square. And when you do that, that's how you get your box collision. Yeah? Yes, depends on every square for every size. Yes. Now that's why you see that it starts to get more and more complicated, right? Because as I said, like as I said for Alberto, you all of the because yes, this will be based on a delta. You cannot store that delta because that delta is different depending on the point of reference, depending on the square, right? So every square is going to have a different point, and that's when we will get into. Actually, I should have been talking about this. I should be talking about that. Like because that's the more pressing part is how do we actually make multiple bodies collide? Because now we have let's talk about that real quick before I go. Is that right now we only have two two bodies that are constantly checking against each other, right? We have one body, we have this body that is checking against this body, right? This body checks with this body, right? But what if there's another body, right? If there's another body, then this body has to check with this body, and this body has to check with this body, right? And what if there's another one? Then this body has to check with this one has to check with this one, this one checks with this one has to check with this one, and then another body, and then this body has to check with this one has to check with this one has to check with this one has to check with this one, and if you add every time you add one more, it increases. I think this is factorial. So every time you increase this, like it increases the amount of calculation increases factorially. So this can get nasty very, very fast. I think no, maybe it's exponential. I don't know the rate of growth. But for example, you've been studying a little bit of this, right? Maybe yes or no? Yes. Whatever. Uh, but yeah, so the rate of growth, this is a thing of calculus. Uh, that basically, yeah, depending like every time that you add another node, the amount of calculations that you have to do to check that node. And think that like the games that you normally see, do this with like thousands of items. Okay? So think that thousands of items that have to check with every other thousands of items. The amount of calculations are monstrous, absolutely monstrous. So the ways to make this efficient is rocket science. It's very complex, but it's very cool. This is actual computer science. Computer science is making things like this efficient.
Trees, like, are you talking about like the trees?
This is okay. I know, but for example, you're talking about one thing would be like linked trees,
Yeah.
but this is not a linked tree. Like the one of the ways of going about this is using a heap. So a heap, like a heap structure.
Sure.
So the most common or like the lowest of something goes to the top. The Dorito structure. That's what they should call it. But yeah, this all of this type of stuff. There's this is way more advanced. We don't need that to solve this. There's a efficient way to solve this. I'll get into that later. But it is beautiful. It is very beautiful when you see how inefficient this is and how easy it is to make it not that inefficient. Okay, it is beautiful to see how, like, for example, let's just count this real quick. Okay, let's just count this. Okay, so for two items, right? For two items, we have to do one calculation, right? Because we just check the distance between this guy and this guy, right? For three items, we have to do one, two. This guy is one, two, yeah. Then one, two, and then one, yeah, one, two, one.
One, two.
Well, okay, so it truly the thing is that depending on how you make your algorithm, like it will that's kind of the solution to it, but whatever. So the thing is that yeah, the thing is that when you make the algorithm, you make them check against each other for in a loop. So basically, you end up doing like one, two, one, two, one, two. So you end up having six. So for three, it becomes six. Okay, this is the bad way. Okay, because with every other circle, yeah,
Okay. So
yes, yeah. So now for four, let's see how much four gives us. So four, so one, two, three, one, two, three. So three times four, 12. Yeah.
one, just two.
Uh, no, yeah, you're right. You're right. Yeah. You're right. You're right. Yeah. In this method, this is the bad way to do it, but yes. Yeah. Uh, for five, it'd be 5 times 4, 20. For six, it'd be 6 times 5, so 30, and so on and so on. But and keep in mind that this is happening 60 times every second. Okay? So you have to do two calculations a second, two calculations. So now two calculations every 60 of so it is 60 times two. So, no, 2 times 60. So you do 120 calculations every second times 60,
360.
360 calculations every second. And then, and then it gets just bigger and bigger and bigger, right? I can do this one real quick. So 6, 12, 12, 0, 700, 720. So look, on on only four items, you have to do 720 calculations every second. That's a lot. That's a lot. That's a lot. That's bigly calculations, okay? And so on and so on. I mean, I can keep doing this. So that would be 20. It's actually easy. 0, 0, 6 times 2, 12. So 100, a, a thousand, 1,200 calculations every second, only with five items. You see how monstrous this thing can get? Yeah. Imagine that you would have to do four. And also this is times four because you have to do four inequalities. Yeah, well, actually no, because well, in the circle you will have to do basically one inequality. So this is two calculations. You have to do one inequality and one hypotenuse. I have to get one Pythagoras. So two calculations. So this would be, and then this times two.
It's difference an overall number. What is that?
What do you mean?
Because you're multiplying 2 times 60, 120 times 2, what is the overall number? What is it supposed to be? What are we calculating technically?
The amount of operations per second. Yeah. So I'm doing 120 and each of these 120s is two operations. It's an inequality and Pythagoras, right? So imagine that you would have to do 240. You would have to do 240 inequalities. Well, no, 120 inequalities and 120